Okay, inverse relations. What is the inverse of a relation? A relation that reverses another relation. Wow, so profound. Notation, the inverse of a relation, r, is written as r to the negative first power. So if you ever see that in math, r to the negative 1 power, that means that it's the inverse. Okay? So if we're given r as 0, negative 7, negative 1, 2, negative 4, negative 2, 6, 3, the inverse, we're just going to flip all those points. So that's negative 7, 0, 2, negative 1, negative 2, negative 4, 3, 6. Okay, and a function has a one-to-one relationship if the relation and its inverse are functions. So that means that the relation is a function, and then the inverse is also a function. Okay? And if you remember back to like 4 days ago, or 4 class periods ago, we learned the vertical line test. Sorry, there's like this fuzzy thing flying around my face right now. Okay. We learned the vertical line test to determine whether a relation was a function. Now, to determine whether a relation has an inverse, we're going to use the horizontal line test. And both the relation and its inverse must be a function in order for it to be a one-to-one function. Okay? So let's look at this. We're just determining whether these are one-to-one. So to be one-to-one, it must pass the vertical line test and the horizontal line test. So vertical line, yep, yep. So that is a function. This one, yep, it crosses that vertical line test. Nope, sad. No, not one-to-one. Sad, sad. This one, yep, yep, yep. This one, yep, yep, booyah. This one, yep, no, because that is just a line right there. There's no way that that is crossing the horizontal line test. So that is absolutely not a one-to-one function. No, that is not even a function. Nope. Its inverse is a function, though. Interesting fact. Okay? So the notation of the inverse of a function is written as f to the negative 1 of x. Not all functions have an inverse function. And then to find the inverse, you're going to replace f of x with y. You're going to interchange the x and the y. And then you're going to solve for y. Then last, you're going to rewrite the y as f of negative 1 of x. Okay, so you're really just switching your x and your y's. First, on all of these, you're going to plug it into your calculator and make sure it passes the horizontal and the vertical line test. So we have 4x minus 8. That passes the horizontal and vertical line test, so we're good. Now we're going to switch our x and our y's. So this is, remember, f of x equals y. So that's y equals 4x minus 8. Switch those, so x equals 4y minus 8. And we're going to solve that for y. So add the 8 over, divide by 4. So you get y equals x plus 8 over 4, which is the inverse. Whoops. And I don't want you, another mistake, of course. Don't write it as y equals, write it as f inverse of x equals x plus 8 over 4. Okay? Next one. So we're going to plug it in and make sure it passes the horizontal and the vertical line test. It does not pass the horizontal line test. It does pass the vertical line test, which means it's a function. But it does not have an inverse because it doesn't pass the horizontal line test. So we can't even find the inverse of that one. Okay? If we look at this one, that passes both the tests. So I'm going to switch my x and my y's. Add that 7 over, divide by negative 1, square both sides, subtract 2. So you get y equals negative x minus 7 squared minus 2. And I forgot to do the thing again. So this should be f inverse of x. Cool? You can do E, G, and I. So, and those are the answers for those ones. Okay, and two functions are inverses if they reflect each other on the line y equals x. So this is how you determine it graphically. So if we look at this, we can graph that. And remember the point slope form, so y equals mx plus b, where m is your slope, b is your y-intercept. So this is crossing at -6. It has a slope of 3, or 3 over 1. So I'm going to put a point at -6, go up 3 over 1, up 3 over 1, and there's the line. I'm going to find the inverse by switching my x and my y. And solving, so you get x equals 3y minus 6. X plus 6 equals 3y. Divide by 3. So y equals x plus 6 over 3, which is the same thing as x over 3 plus 6 over 3, which is 1/3 x plus 2. So my slope is 1/3. My y-intercept is 2. So I'm going to cross up there at 2. Go up 1 over 3. Up 1 over 3. And there's that line right there. It needs to cross the line y equals x. So right there, it does. It reflects that line perfectly. So that is a function, and we verified it graphically. Let's look at this one. So we have x cubed plus 4. Now there's the x cubed graph. That plus 4 is going to move it up 4. So I'm going to go up 4 and draw that right there. And sorry, I drew that with my finger on here, so it's not very good. We need to find the inverse, so I'm going to switch my x and my y's. Subtract that 4, cube root. So you get y equals the cube root of x minus 4. There's the cube root graph. That minus 4 is inside, so it moves it right 4. So I'm going to go right 4, graph that right there. Needs to reflect over the line y equals x. Boom. And it does. Super awesome. So they are inverses. Okay, now two functions, f and g, are inverses if f of g of x equals x and g of f of x equals x. So if we have f of x equals x squared minus 5 only when x is greater than 0, and g of x when x equals the square root of x plus 5. So this is only when x is greater than 0, because if we graph this, it's a graph that looks like this. Notice how that is not, it does not pass the vertical, or it passes the vertical, but it doesn't pass the horizontal line test right here, because it crosses at both points. But if we just look at when this is greater than 0, so if we just look at the right side of this side right here, that does pass the horizontal line test. So that is why it's just greater than 0. Okay? So we're going to do f of g of x and see if that will equal x. So I'm going to plug g of x into f of x. So I get the square root of x plus 5 squared minus 5, which is x plus 5 minus 5, which is just x. So we're good. We're going to do same thing with g of f of x. So you get the square root of x squared minus 5 plus 5, which is the square root of x squared minus 5 plus 5, square root of x squared, which is x. So we are also good. Cool? Let's save the back. Remember to take the quiz. Thank you guys for being who you are, and thank you for being amazing. Goodbye.